Since time immemorial, mankind has gazed at the stars with wonder, seeking answers to the profound questions of our existence. The cosmos, in its vast and enigmatic expanse, has beckoned us, ignited our curiosity, and fueled our dreams of venturing beyond the confines of our pale blue dot. The beauty and mystery of the universe have inspired countless generations to look up and ponder what lies beyond. Today, as we stand on the cusp of a new era of space exploration, the age-old yearning to reach for the stars is more palpable than ever. With each technological advancement, we inch closer to making the dream of interstellar travel a reality. Imagine a future where traversing the vast cosmic ocean, journeying to distant stars and galaxies, is no longer a figment of science fiction but a tangible reality. A future where humanity has established colonies on distant planets and space travel is as common as air travel is today. For centuries, the speed of light, a staggering 186,282 miles per second, has stood as an insurmountable barrier, limiting our reach into the cosmos. This speed limit has defined the boundaries of our exploration, making the vast distances between stars seem almost impossible to traverse. A journey to even the closest star system, Alpha Centauri, would take tens of thousands of years with our current technology, a daunting timescale that makes interstellar voyages seem like an impossible dream. Yet this challenge has not deterred the human spirit. However, the human spirit, imbued with an unyielding thirst for knowledge and exploration, refuses to be daunted by such limitations. Throughout history, we have overcome seemingly insurmountable obstacles through innovation, determination, and sheer willpower. Enter the fascinating realm of warp drive and wormhole travel, concepts once relegated to the realm of science fiction, but now being seriously considered by physicists and engineers. These groundbreaking ideas could revolutionize our approach to space travel. These revolutionary ideas, if realized, hold the key to shattering the cosmic speed limit and unlocking a future where interstellar travel becomes not just possible, but commonplace. Imagine the possibilities that await us if we can overcome the barriers of distance and time. The allure of exploring new worlds, encountering alien civilizations, and unraveling the mysteries of the universe drives us to push the boundaries of science and technology to venture into the unknown with both audacity and hope. It is this relentless pursuit of discovery that defines us as a species and propels us forward into the cosmos. Imagine for a moment a vast sheet of fabric stretched taut, representing the very fabric of space-time. This fabric is not just a metaphor but a visual representation of how space-time behaves in the presence of mass and energy. Now, picture a heavy object like a bowling ball placed in the center, causing the fabric to sag and curve. This sagging effect is akin to how massive objects like planets and stars warp the space-time around them. This, in essence, is how gravity works according to Einstein's theory of general relativity. Massive objects warp the fabric of space-time around them, creating the force we perceive as gravity. The greater the mass, the more pronounced the curvature, and hence the stronger the gravitational pull. Now let's introduce a spaceship onto our cosmic fabric. Imagine this spaceship as a small object on the vast expanse of space-time, navigating through the curves and bends created by massive celestial bodies. Instead of traveling through space at breakneck speeds, warp drive proposes a rather ingenious alternative: warping space itself. This concept suggests that by manipulating space-time, we can achieve faster-than-light travel without actually breaking the cosmic speed limit. The concept, first popularized by the science fiction franchise Star Trek, hinges on the idea of compressing the space-time in front of the spaceship while simultaneously expanding it behind. This dual action creates a bubble of warped space that propels the spaceship forward. This manipulation of space-time, theoretically, would create a warp bubble around the spaceship, enabling it to ride on the wave of distorted space-time, much like a surfer riding a wave on the ocean. The spaceship would glide effortlessly, carried by the very fabric of the universe. The beauty of this concept lies in the fact that the spaceship itself remains stationary within the warp bubble, circumventing the limitations imposed by the speed of light. This means the spaceship doesn't move through space in the traditional sense, but is carried along by the warped space-time. Instead of traversing through space, the spaceship, nestled within its space-time cocoon, would be essentially propelled forward by the warped space itself. This revolutionary idea could one day transform interstellar travel, making distant stars and galaxies accessible within human lifetimes. The allure of warp drive, with its promise of shattering the cosmic speed barrier, is undeniably captivating. Imagine traversing the vast expanses of the universe in mere moments, reaching distant stars and galaxies that are currently beyond our grasp. However, like all groundbreaking scientific endeavors, the path to realizing this dream is fraught with formidable challenges. Theoretical physicists and engineers are working tirelessly, pushing the boundaries of our understanding and technology. The most significant hurdle lies in harnessing the astronomical amount of energy required to warp spacetime to such a degree. This isn't just a matter of scaling up our current technologies, it requires a complete rethinking of how we generate and manipulate energy. Calculations suggest that creating a warp bubble capable of propelling a spaceship at faster-than-light speeds would require energy equivalent to the mass energy of Jupiter, a truly mind-boggling figure. This is not just a technical challenge but a conceptual one, pushing the limits of our current scientific paradigms. To put this into perspective, it would take the total energy output of our sun for several years to generate such a colossal amount of energy. The sun, our most powerful natural energy source, would need to be harnessed in ways we can barely imagine. Clearly, our current energy sources, reliant on fossil fuels and even nuclear fission, are woefully inadequate for the task. These traditional methods, while powerful, fall short of the astronomical requirements needed for warp travel. We need a paradigm shift in energy generation, perhaps tapping into the very fabric of spacetime itself, if we are to even dream of powering a warp drive. This could involve harnessing exotic forms of energy or developing entirely new technologies that we have yet to conceive. Beyond the energy conundrum, another formidable challenge lies in ensuring the stability of the warp bubble. Theoretical models suggest that maintaining a stable warp bubble is no small feat, requiring precise control and constant adjustments. The mathematics behind warp drive suggests that the bubble itself could be highly unstable, prone to collapsing without warning. This instability could be triggered by a myriad of factors, from external cosmic forces to internal fluctuations in the energy field. Such an event would be catastrophic for the spaceship and its occupants, potentially crushing them into oblivion. The consequences of a warp bubble collapse are dire, making stability a critical focus of ongoing research. Therefore, maintaining the integrity and stability of the warp bubble throughout the journey is paramount, requiring precise control over the distribution of energy and the geometry of spacetime. This involves not only advanced technology, but also a deep understanding of the underlying physics, ensuring that every journey through the cosmos is as safe as it is swift. While warp drive grapples with the challenges of distorting spacetime, another theoretical concept, wormholes, offers a tantalizingly different approach to conquering the vast cosmic distances. Imagine, if you will, the fabric of spacetime as a sheet of paper folded in half, with two distant points on the paper representing distant regions in space. Now picture a tunnel or a wormhole, connecting these 2 points through the fold in the paper. By traversing this tunnel, one could, in theory, travel between the two distant points instantaneously, bypassing the vast expanse of space that separates them. Wormholes therefore offer a shortcut, a cosmic bypass, through the fabric of spacetime, potentially allowing us to traverse unimaginable distances in the blink of an eye. Unlike warp drive, which involves manipulating the fabric of spacetime around a spaceship, wormholes are hypothetical tunnels that are thought to exist naturally, albeit fleetingly, at the quantum level. The challenge lies in detecting these ephemeral tunnels, stabilizing them, and most importantly, enlarging them to a scale that would allow a spaceship to pass through. The very nature of wormholes, shrouded in the enigmatic world of quantum mechanics, makes their study and manipulation a daunting task.